So today I am pleased to introduce today's session, RAG Evaluation with Ragas, and our guest speaker, Christy Bergman. Christy is a passionate developer advocate at Zillow. She previously worked in distributed computing at any scale and as a specialist AI and ML solution architect at AWS. Christy studied applied math, is a self-taught coder, and has published papers, including one with the ACM races. She enjoys hiking and birdwatching. Welcome, Christy, and get started with our session today.
Thank you, Sachi. Good morning, everybody. I'm Christy Bergman. I am a developer advocate at Zillow, the maintainers of open source vector database Milvus, which I'll be using in today's demo. And this is my LinkedIn. Please feel free to follow me or connect with me. So just a few words about us. Zillow is the maintainers of open source vector database Milvus, and you can think of vector databases as either open source or closed source. But our company does have a foot on both sides. So we have the open source Milvus, which was donated to the Linux Foundation. It has a very generous Apache 2 license, which means that you can build on top of open source Milvus and even charge money for your products. So that's a Linux Foundation managed project, which means we can't change that licensing even if we wanted to. And then Zillow is the managed Milvus, which runs on AWS, GCP, or Azure. And we do have free tier versions of Zillow as well, so you could get started on either side for free. People have probably heard of these 3 pillars of generative AI. So the computation, those are the CPUs, GPUs, TPUs, and even Grok LPUs. And then the models are super important. We have, just move this little thing out of the way. Okay, I can't move that. So the models we have, for example, the GPTs of OpenAI, Meta, Llama3s, and I'll be demoing that today. And then we have, we think the most important thing is the embeddings, the unstructured data, sorry. Okay, so we think there's a lot of opportunities in unstructured data. And yeah, I'm going to be jumping into that today, and also keep your eyes out for the Unstructured Data Summit in Q4 of this year. All right, so my talk today, I'm going to be just doing a quick introduction to RAG, and then talk about a couple challenges with RAG, and then do a demo of RAG evaluation methods. I really wish I could move this thing. Fuck. Oh, there it goes, finally. All right. So up until just a few weeks ago, I was able to go into Gemini and ask, for example, list 3 politicians born in New York. And one list would be Hillary Clinton. But then if you go to Wikipedia, you can see that she was born in Chicago. So that's an example of a hallucination. And then as of a couple of weeks ago, I noticed that it changed and I can't get anything about elections or political figures anymore. So why do these LLMs hallucinate? Because they are trained on sequences of words or tokens to predict next tokens or mask tokens. And so, for example, if you were to predict the chicken walked across, it's probably the road. But because these large language models are trained on so much data, including possibly Reddit, for example, and you can imagine that there's all kinds of unusual things being inserted into the trained data. And then where do the vectors come from? So the vectors come from these deep learning neural networks, not the very last layer, which is usually for like maybe just 9 different classes to map the inputs into numbers, but the next to last layer. And the reason for that is, so researchers have learned that this is where all of those trained weights are stored. So you can think of this whole neural network as like a big function, f of x. And the x's are the unstructured data inputs, And the F is the transformation through all these trained weights into that last embedding layer, which represents the f of x equals y. The y's are vectors, and these y's represent the knowledge of this model. You take those vectors, you store them maybe in a vector database, and then you can retrieve them. Skip that for now. So, which you can use them for RAG. So for example, this is the RAG pattern. You take your data, you embed it using an embedding model. You store those into a vector database. And typically that part is done offline first. Then you would deploy your chat app, maybe, for example, with the knowledge base already filled in. And the user would come along real time and maybe ask a question. That question needs to be encoded using the same embedding model. And then because vector calculations are super fast, the approximate nearest neighbors can be calculated very fast on the fly in real time. What's retrieved from the vector database, we call it the context. We stuff it along with a question into the prompt. And then this prompt goes to another model, the generative model, and we just call them LLMs for the chat GPTs. And then hopefully you get out a more reliable answer. All right, so let's talk about a few challenges with RAG. So number one is choosing your embedding model. And a common place to get started is this Hugging Face MTEB leaderboard. You'll see you can sort it by retrieval task and see the top ranked models. And yeah, choose one. I don't want to talk too much about this, I guess. One of the a surprising development in this year is that people used to think that the longer the length of the embedding vector, the more accurate. But with OpenAI's announcement in February of this year, they showed that using a technique called Matryoshka embeddings, or MRL, Matryoshka representation learning, during the training time, that you can actually take an embedding model and use either 512 or 1536 dimensions and actually get exactly the same accuracy from the smaller dimensional vector, which means this is important because if you've got like a third of the length of a vector and still getting the same accuracy, that means a smaller memory amount of data for the amount of data that you need to store. It also means lower latency or faster response times. Another challenge is choosing your index. So we have, if you go to our docs, you'll see a whole bunch of different indexes to choose depending on your use case. So flat means you're going to do an exhaustive search. This is good if you've got very small data. It's a brute force search. The approximate part of ANN, approximate nearest neighbors, is because normally for very large data, the search is stochastic, meaning that you use a data structure for the index. I think I have a few slides for this. So for example, this IVF flat uses clustering as its data structure, so that then you specify how many clusters you want to search. And the HNSW indexing type uses hierarchical navigable small worlds, or hierarchical graphs, with the sparsest graph at the top. So that means, like, as you enter the top layer, because there aren't that many nodes to search there, the nearest neighbor search is super fast. And then you move to the next layer, which is a little bit more dense, and continue on this way. So the overall search this is a very efficient search algorithm because you're jumping from layer to layer, and it's actually a big O of log n. So it is actually one of the most efficient search algorithms for large data. But there are different reasons why you might choose different indexing strategies. And then finally, the one I'm going to delve into in my demo today is chunking. And you can think of chunking these days in a RAG in the RAG pipeline as something like the data featureization used to be part of the traditional data science pipeline, where the features like red, green, blue need to be mapped to 1, 2, 3, for example. And the way that you do that featureization of turning data into numbers can have a difference in the outcome of the accuracy of your model. Today's paradigm in RAG is this chunking step, especially for text data. So it's still a little bit of an art. So I'll jump into this a little bit more. The first entry point is you need to think about what kind of data you have. So depending on what kind of data you have, whether it's conversation chats or whether it's documents, which I'm going to give a demo today, or whether it's like a Q&A pair lecture data, there are different techniques that are the most efficient way to handle that kind of data. I'll talk a little bit about 3 chunking methods today. So the first chunking method, for example, is depending on the structure of your data. For example, if you've got HTML data, which I have, the HTML page probably has headers in it, which lead to natural structure. There is a trick. It is kind of tricky because a lot of web pages, including ours, our Milvus docs, don't have straightforward H1, H2s, which I'll show in my demo. I made it not. Maybe this technique doesn't work for everybody, but high level, the idea of a web page is you've probably got a title, you've probably got headers, and then within each header you've got text. And if you just take the naive text and only chunk those, you lose some you lose some context. Whereas if you were to just put those the headers into the text, and usually they're very small, so you're not losing much in terms of the text chunk size. You actually, it's like a little hack where you're getting a cheat short way of getting more context into each chunk. Another technique is called small to big, where you have the small chunks of text, and then you also map them to maybe the parent documents of those chunks. So maybe you've got 512 as your chunk, and then you map it to the parent document so that you could reach. So the idea is that you do vector retrieval at the small level, and then you do document retrieval at the big level, and you send this parent document to the LLM for generation. Okay, I'm gonna skip over here to okay, and this is another fun slide to think about when you're trying to optimize your RAG pipeline. Is we had another speaker from Langchain at one of our unstructured data events, and he spoke about these needle in a haystack experiments that show that especially from this archive article, there was research that showed that just adding more documents into the context window of the LLM isn't always better. So the y-axis on this chart from the paper is accuracy, and the x-axis is the number of documents you add, as well as the position of those documents. And in general, the more documents you add, you do risk losing accuracy. But then there's a curious curve here, which led people to do more experiments, which are called needle and haystack, where they showed that where all the green stuff is the most accurate retrieval, that you get the most accurate retrieval at the beginning and at the end. And then Lance Martin, who came and spoke to us in San Francisco, said, actually, there's even a little bit more refinement about that the highest accuracy is really at the end. And then finally, there's the LLM models themselves to think about in your RAG pipeline. We have I really like to follow this guy, Maxime Le Bon, on Twitter, what he does is he takes this thing that's called the LLM-as-a-judge leaderboard for foundation models, and he makes a nice visualization where green are the open source models and red are the closed source models. And people were pretty excited tracking this for a while because it seemed like the gap between the accuracy of the two models was decreasing. And then we finally crossed over that gap this year with the Llama3. Actually, no, sorry, the crossover was Claude. Right, and just a few words about evaluation. So recall, we've got the encoder models and the decoder models, which are different types of models. For example, I might be using an encoder model from Hugging Face, and I might be choosing this GPT-4o from OpenAI. Let's see. So the thing to keep in mind is that particular foundation models that are on the kind of tweeted about leaderboards, they have certain there's performance that is closely tracked by researchers, but a model, or either an embedding model or a generative model that appear high on a research leaderboard might not be the models that perform the best on your particular system, because your particular data is different, and it might be that a much lower ranked model actually performs just as well as a higher ranked model, which means you might be able to get by with smaller embeddings or a local model, for example, to save money and latency in your system. So this is why evaluations are really important to do on your own data in your own RAG system. And it is a tricky topic. I think some of the things to keep in mind is that these LLM evaluation models are based on this concept that came out in 2023, LLM-as-a-judge, from UC Berkeley Skylab with Jan Stojka. So this really changed because previous to this paper, it was thought that evaluation needed to be done with human annotations, and this was really expensive. So it used to be that people thought, oh, you need thousands of data points and you need thousands of human labeled data points. But with the paper, it showed that actually GPT-4 is just as good as a human. And this is because there is stochasticity even among humans. Not all humans will agree with each other in terms of which answer A or B is better. And in fact, there's humans tend to agree with each other about 80% of the time. And if you apply a LLM as a judge or as a critic in these evaluation methods, they also agree with each other, and with humans 80% of the time. So yeah, you can replace a human with an LLM is the concept. And this has really changed evaluation and made it possible to do evaluations in an automated way, which I'm going to show. And then also the data points, you don't need as many, you don't need thousands of human labeled data points anymore. This means you can get by with maybe 20 human labeled data points, which makes evaluation just a lot more approachable. So there are a few caveats about the LLM-as-a-judge. We know that if you ask it to score different types of things, like whether is the answer correct, is the style in the way that you want, or is it complete or comprehensive? LLMs are very good at the first two categories, but they're not so good at the completeness type of score. So you should not ask that type of question for an LLM-as-a-judge evaluation. And the other thing that we know about LLMs-as-a-judge is that, let's say you ask it to give a score between a range of 1 to 10, which is actually most people who run reports know that that's not actually a good scoring system. But let's say that was the scoring system, then humans tend to answer midpoint answers, where on the left you can see the charts, whereas AIs tend to answer on the extremes, so either zeros or highest, min or max scores. So that's also some taken into account with the Ragas, which I'm going to use. It's an open source package. They score between 0 and 1 with a digital scale. Yeah, so this is the Exploding Gradients GitHub open source Ragas, which I'm going to use. And what they've done is they've taken RAG as a whole system and evaluate RAG, the whole system, as well as component-wise. Component-wise, you can think of that RAG diagram as maybe a parallelogram of components. There's the user's query. Then there's what is going to be retrieved from the nearest neighbor search of chunks that answer that question. And then you can measure, like, did the retrieved chunks cover the main points of that question or not? Then you've got the LLM generative model, which generates the output. And you can measure, well, was that LLM faithful to the context, for example? And then you've got the ground truth answer. So between all of these all of these like components of a RAG, you can get different metrics out. All right, back to my demo. See, can everybody, maybe I should make this a little bit. Okay. All right, so I have this demo on, I can share the GitHub link later. It's on if you search Milvus Bootcamp, they're out there on GitHub. Yeah, so here's my RAG diagram. Bring in the data, pass it through an embedding model, save the vectors, come along, ask a question, search nearest neighbors between the embedding of your question into vector and your knowledge base of vectors. What's retrieved from the knowledge base of vectors, you stuff it into the prompt along with the question and generate an answer. So the data I'm going to be using for my evaluation is going to be our own documents, milvus.io.docs. So they're public web pages of documentation, technical docs. And I load them and I download them locally, just so I don't have to download them every single time. And then I clean them up and I see a total of 22 documents, and I can see that, yeah, so I can see the websites for each one of them. I also want to give a lot of kudos for the demo I'm going to give. Can I change my... Okay. Zoom's kind of in my way. Okay. Here. Oops, nope, that's this one. I will give out this link as well. This is a Medium article that I wrote. And then I wanted to give a shout out to Greg Camerot. His original article here is 5 levels of text splitting, which I'm going to show in this chunking. I'm going to show 3 of them. So there's this, depending on your document type, HTML, there's the small to big, and there's semantic chunking is what I'm going to show today in my demo. All right, so let me just jump down here. I'm going to skip like how I initialized my LLM for pipelines using Langchain. Skip all this. I have some canned questions. Okay, so here's the first chunking method, small to big. And the idea of small to big is that I showed it in the slides. You've got the small chunks, which you're going to recursively split. And recursive splitting means you've just got a fixed length and you have a fixed overlap, and you just kind of dumbly go through all your text and split it into 512 links with a 10% overlap. Then you've got all of those small chunks belong to a parent document. So we're going to keep track of that parent document. And so, yeah, this is how you do it. In Langchain, for example, you just need to define these two, the splitter and the retriever, and split the child splitter into the fixed links. And then you can see they are as expected around 512 with a few variations. And then you have your parent document, and that should be something bigger. So I chose 1586 as the parent chunk size. And again, if you if you look at the parent chunk sizes, they are pretty close to 1586. And then what you need is two stores. I'm going to use Milvus as my vector store for the child chunks. And then I'm going to use just a built-in Langchain document store for the parent chunks. And what you do is you define a retriever with the child and the parent, and add those documents, which was my HTML web pages from our Milvus technical docs. And now you can ask it a question. So for example, I ask it, I ask it some question. I pass it in to the retriever, enumerate the result outputs, and I can see here the question was, what's the distance metric? And I can see that it did retrieve chunks relative to that question that was asked. And same thing with parent documents. I can see that it retrieves very long parent documents. And so what you do is stuff them into a context to send to the LLM. And here I'm taking advantage of Lance Martin's words of wisdom, that I reverse the context so that the most relevant context, the top K are last. And then I get back an answer. Okay, so looks like I have 15 more minutes left of demo. So I'll jump into the next technique, and which is the semantic chunking. And this is really unique, pretty interesting. And all thanks go to Greg for coming up with this. So basically the concept is that you take the fixed length chunks that we have, you calculate a cosine distance between adjacent chunks, and then you plot those distances. You look for outliers of adjacent distances, and that kind of tells you intuitively where you should make chunk cuts. So for example, he has these nice graphs where he showed, okay, this would be my chunk 1, 2, 3, etc., based on a more intuitive outlier distances. So that's what this is doing. So again, we'll go into, I'm not going to code these myself from scratch. I actually do have a notebook where I tried coding all this stuff from scratch. But I'm going to use in this demo, I'm going to use Langchain sequential semantic chunker library. You just initialize it with a particular embedding model. I kind of skipped over that in my code earlier. I'm using the Hugging Face open source embedding model. And and then at this point you just call it, because all it's using statistics to calculate where the chunkings should go. And I see that my 22 docs were split into 87 semantic docs in this case, and I can look at my chunk lengths, and I do see something was not able to chunk. It might be a web page that's only like code or something. That actually I already looked at it. It was a web page that was only code that was not able to split very well. But most of the other web pages were able to split into fairly large chunks. You can try it with percentiles or as standard deviations as your chunk points. And again, you follow the same steps. I can use Milvus as my vector store, and I can test it with a question, ask the question, get back my results, and loop through what was retrieved. Here I asked about IBF flat. Again, I just combine those, put them into a context that I can send to the LLM. I tried this HTML chunking, and this is where I have to say that our particular docs have very tricky structure for the H1 and H2. You can see, like, you kind of have to look at the way your documents are coded up, and mine were I kind of ended up scratching this because I ended up building a whole bunch of custom code. They're not nice and neat H1, H2, H3s. They're like weird parse things that I had to try to figure out. But yeah, I did a whole bunch of kind of scratch work to to parse out our HTML docs. And I can split 22 initial docs into 63 HTML chunks. So you can see like H1, H2, H3 out of them. And you can see my HTML chunk links of what I got out. All right. So those are my 3 chunking methods that I tried. And so let me go back to, still only half an hour, so I've still got half an hour left of this webinar. All right, so high level, what we're doing with our RAG pipeline is I'm playing around with chunking methods. So I did the fixed length chunking, I did the small to big, and I did semantic chunking. Some other levers you have to pull for optimization is, besides the chunking strategy, you can swap out the embedding models, or you could swap out the generative AI models. In my demo, I actually, I'm gonna, let's see, do I have like a nice review? Okay, so in my demo, I swapped out 2 different embedding models, an OpenAI model and a Hugging Face model. I guess I scrolled up there. So I'm using, from Hugging Face, I'm using this one called BAI, BGE large. You could also use, and then the way I did my experiments is I just ran through this notebook twice. I ran it once with the Hugging Face models, and then another time with this particular text embedding 3 small that I showed with the smaller dimension 512, since it gets the same accuracy as the 1536. So those are my 2 iterations of the embedding model. And then I also iterated on the LLMs. And for the LLMs, I actually tried out 6 different LLMs. I tried out Mixtral. I tried Llama3 from Meta, and GPT 3.5. So let me just jump to my code where I try those out. And I'm going to add a table of contents to make this easier, because I realize myself trying to scroll around is kind of hard. So I'll add a table of contents before and check this in again. All right. So when I do the LLMs, you need to create your system prompt. And here's where I iterated with Llama3, Ollama. So you just follow their instructions on their website to download Ollama, pip install Ollama, pull a Llama3 model, and then if I run this here, I can see that that it's running the Llama3 latest. That it's GGUF format, which means it's formatted for CPU. And I can also see that I've got the highest level of quantization, which is kind of interesting to see. So, and that makes sense, because I have the poor person's laptop. I have an M2, so it's an older Apple laptop, and I've only got 16 gigabytes of memory. So I needed this to be the smallest possible. And so, yeah, I can send it to Llama3 and I get an answer. Default index is cosine is what they said. I can also send it to a bigger Llama, because that Llama that I ran locally with Ollama was pretty small. So I can also, yeah, I can also send it to, here I'm using the 8 billion model, so that now it's bigger. And I'm using AnyScale just because I heard AnyScale endpoints were good. So tried that out. I can see, oh yeah, this is to point out also, look at this latency. So my Ollama took 3 seconds. And you know, you can use an endpoint. It takes a little bit less. That's why a lot of people use endpoints, even though using an open source model locally is cheaper. Sometimes there's a latency concern. So there's all these different trade-offs in your RAG pipeline to think about. I also tried it with OctoAI, just to see if it was, what the difference was. I actually don't see a clear answer right there. I see clear answer is L2 here. Also try Grok, and this is amazing, 0.37 seconds, it's super fast. I do see a clear answer there. I also tried out Claude. I'm not going to demo that right here because it's very expensive to try out. I can try out Mixtral. Again, I think I used AnyScale endpoints to try out Mixtral. And the Mixtral I tried out was the 87B instruct. And I do see an answer is L2. And the latency is not too bad. And then let's try OpenAI, of course. And GPT 3.5 Turbo is what I'm using because I don't need the super fancy model just for a simple question. And yeah, I do see two answers, L2 and IP. All right, so now we're ready for evaluation. So I'm going to use, I've got links to the paper, the code, the docs, and a blog. And so all you need to do is pip install Ragas, and they do use Hugging Face datasets behind the scenes. One of the people asked me, like, what are the tricky parts? Just keep in mind that they do use datasets. So I created this, and also you do need those 4 components. So I have 4 questions here. I have the ground truth answer for each question, and then I have my context that were retrieved for each of these different chunking methods. Then I have the context that we retrieved using a different embedding model. And then I should have 6 different columns of answers for the 6 different models. So this is the type of stuff you need for the evaluation. And in a production, you should have about 20 questions. I only was, to be quick, I only have 4 questions here. So I just put those into a CSV. And then you do need to convert them into a Hugging Face data set, which I have some code here to do. You assemble them in terms of what's the ground truth, what were your contexts, what are your answers. Then you need to know what you're evaluating because there are different metrics. If you recall from this high-level chart, depending on what you're evaluating, the context of the LLM, you're going to have different, all these different metrics are possible. So you import all those metrics, and then you have to define, depending on if you're evaluating the context or the answers, which metrics to use. And then the other tricky part, I think here, I mean, it's not tricky once you know it, but that anything that's supported through Langchain is also supported in Ragas. And so to save money, because this can get expensive, I replaced the default OpenAI model with my local Ollama model. And then I'm using open source BAI as my embedding model. So you need to set those wrappers to be able to change the model. And what I found is my initial eyeballing, at least for my RAG pipeline, is I'm very happy using Llama3, even this super quantized version on local Ollama. Number one, because I'm saving all that money, 6 different metrics to calculate per question. And then you saw I had 6 LLMs, 2 embedding models, and 3 chunking methods. So yeah, 6 plus 3, 12 different permutations, 6 different metrics each, 72 LLM calls. That gets expensive very fast. And I'm only using 4 questions. So imagine if you were using the full 20 questions. So for me, I saw by eyeballing the evaluations that came out of this, I'm very happy, and I would stick with Ollama, because for my evaluation, I'm not too worried about real-time performance. And yeah, so this is what I run it through Ragas. It calculates for all the different chunking methods. For example, I output my a final metric. So for me, what I chose is, rather than outputting 3 different metrics for context to measure the context, I just combine them down here in my code because I have precision and recall, I just combine them into a traditional F1 score. So here's my F1 calculation. and I return an average retrieval F1 as my final score, which is what I'm going to report as my scoring method for the context. And so here you can see the outputs for the different chunking methods. And just to make it easier, I just output them here in a little easier format to read. But meantime, Ragas does give you all of this output in terms of for your questions for each different context type that you had. So here's my recursive context. I get the different scores, recall, precision, and my calculated F1 for each question. And then for HTML and for the parent context, big to small, and for the semantic context. And then I even tried summarizing that semantic context because it was so big. So yeah, I tried all these different permutations. And in the end, you can see that it was the parent context, the raw parent context that had the highest accuracy, followed by a very straightforward recursive context. And when I did this over the chunking strategies, over the embedding models, and over the LLMs, the punchline here is that I get the most bang for my buck by changing the chunking strategy. In my case, 84, which is a really huge difference. I got a 20% improvement by changing the embedding model, and I got a 6% improvement by changing the LLMs. And yeah, so that's kind of the punchline. And I think, Sachi, I'll take it back to you.
Yeah, thank you so much for sharing your demo, Christy. You have quite a few questions in the chat and the Q&A
Okay.
About what you shared. So first, what is the optimal chunking for RAG models?
Yeah, so I think what we saw is that the chunking, I don't think there's going to be a straightforward answer. It's going to, number one, depend on the shape of your data. So do you have text data like I had, or do you have, some other kind of like conversation data or lecture data? There's going to be different strategies. So if it's conversation, add memory. That's the biggest bang for your buck. For mine, you can see that it was this small to big chunking, or the parent chunking, that worked best for me. But I think it's really going to depend on your data. And that's why this hard task of evaluations is really important, because you won't know that unless you are able to evaluate your different chunking strategies.
Thank you. And then a follow-up question they had was, what about costing in RAG? Where is the optimal area? I think you kind of answered this, but anything to add there?
Yeah, the costs. So you do need to think about what kind of model, the open source models. I'm very bullish, just from my own, what I've seen, very bullish on the open source models. Right now, I'm very much like the Meta's Llama3 as a critic, but you do need to try out different models as your critic to see which ones are evaluating better. And there is a trade-off between serving up maybe a local model, which tends to have a little bit worse, a little bit slower performance, versus a commercial endpoint where they have like a huge cluster behind what they're serving up, but then you're paying for that cluster through API calls. So yeah, I guess I would say if you are going to do this, definitely have subscribe. If you're doing it individually for demos, I would subscribe. That $20 a month is going to quickly be worth it. If you're a big business, then of course that $20 a month is, you're gonna hit some ceilings there. But at least for an individual, I think it's worth it. The $20 a month if you need that commercial endpoint, or a small business, the $20 a month. Okay.
Okay, thank you. And then someone in the Q&A tool asked, on the distribution of scores chart where the LLM favors high and low answers, does this mean using LLMs as classifiers is not ideal? And what should what would be some methods in order to use LLMs as classifying a response consistently then?
So these are known, and this is what has come out of the research papers. So for example, this paper, and it's a pretty well accepted technique now, this LLM-as-a-judge. So you want, but the thing is if you are, so it comes with so many benefits using the concept of LLM-as-a-judge versus going back to the hand curated thousands of answers. So I think the benefits are really strong. It's just that you do need to keep in mind that there are known caveats with using LLM as a judge or using LLM as the critic instead of a human critic. So the fact that AI tends to prefer extremes versus midpoints like humans prefer. Just keep that in mind. And so Ragas has done that, and they've created metrics and scoring systems that avoid these known pitfalls. But I would say don't throw out the baby with the bathwater. Like, don't just say like, hey, I'm going to skip LLM as a judge as a technique and go back to hand labeled data points. Yeah.
Okay, thank you. And then someone's asking if Ragas is a Milvus product.
No.
It is not, but Christy, do you want to like talk a little bit about like how you can access Ragas?
For sure. Yeah. So here, I think I have a link in my notebook. Oops. All right, so then this is their technical docs. So I could also just like import, like suck this in, and since they're public web pages, and create a little chatbot, a RAG chatbot for you to ask Ragas questions, like I did for Milvus questions. But yeah, their code is over here. So it's called Exploding Gradients, Ragas. So no, it is not Milvus. It's not the same.
Okay, thanks for sharing. And then we'll have the links as well in the in an email. And also the code that she shared is actually in our Milvus bootcamp. I'll provide a link to that soon while I ask the next question, which is Ragas just for Python deployments?
Let's see. Actually, I am not sure about that answer. I would have to look at their web page myself. Okay, move this out of the way and get started. It looks like it is Python. Yes, that's my right now. I'd have to look into that closer, but offhand, it looks like it's Python.
Okay, great. Thanks for clarifying that. And then the next question is, rather than doing all the chunking, is it probably a better ROI to label and pre-process all your data and put them into proper chunks before, and instead worry about other parts of the pipeline?
So my takeaway, and this is also what I've heard from others, other engineers, and I think there's even a white paper that was published by a consortium of AI companies from the AI Alliance, that there is agreement that the biggest bang for your buck comes from the retrieval step. So you saw changing out 6 different LLMs, the answers really didn't vary that much. However, if you change the chunking and the embedding models, there's a bigger improvement. So it is more bang for your buck actually to focus on the retrieval step than the generation step. Now within the retrieval step, in my particular case, if I go to the end here, I did see like this is outside of typical what yeah, so they did a whole bunch of experiments over lots and lots of data. And typically what they saw in the white paper was like around 30% improvement from chunking, and then something really small from the LLM. In my case, I saw a huge improvement by changing my chunking. So I do think, yeah, definitely, it is worth looking at the retrieval step. And you saw it's super easy just to change the LLM. You just change like typically one line, the name of the model, and then you can call endpoints with different models. But it takes more work changing your retrieval and your trunking.
Okay, thank you. And then you mentioned you can swap embedding models. Just to confirm, you can only use one embedding model per Milvus collection. Like, for example, you cannot mix embedding models in one collection. Just clarification on that.
Yes, that is, I feel like that is a pain point. That and it's part of just the theory of vector retrieval, is that if you're going to create a knowledge base and then you want super fast nearest neighbor calculations within a vector space based on unknown questions that are going to come in, they do all need to be in the same vector space in order for that distance metric to make sense. So you're basically calculating either cosine distance metric or L2 or inner product or some kind of distance metric between vectors. So they do all have to be in the same vector space. So they do all have to be created with the same embedding model.
Okay. Well, this is kind of related to that, but how is it possible that you can mix embedding models all with different sizes? And does this mean that all the internal neural networks are constructed the same?
So what they've done, that MRL, Matryoshka representation learning, which has to be done during training time of the embedding model itself, to allow what they call the MRL embeddings. And I think they named it because of those Russian Matryoshka dolls where you have dolls within dolls within dolls. So the idea is that the vectors themselves have subvectors within the larger vectors and more subvectors. And by doing this kind of being aware of those layers at the time of training the embedding models, that you can choose different sized vector outputs. And in that case, in this particular case, I forget the name of my embedding model from OpenAI February 2024 announcement, the two dimensions possible were 1536 or 512 with the same accuracy. So it's up to you. I mean, if you, for me, I'd rather just save the space if I'm going to get the same accuracy. Was it that? I'm not sure. Hopefully I answered that question.
Yeah, let us know if you have any follow-ups in the comments. Someone is wondering, I don't know, maybe you might know this since you've met some of the co-founders of Ragas, what the AS in Ragas is after RAG.
Good question. I have no idea. I know RAG. I don't know why they call it Ragas. Maybe like Rags. Maybe Rags was like, maybe they tried to get the company name Rags or name it Rags, and that was like too generic, so they just, I don't know, I'm just guessing, maybe.
Potentially, yeah, that's what I think too. Last question here. How is Ragas calculating these scores? For example, the context relevance. And is an LLM evaluating or something
Yes.
like the cosine similarity used by vector search? That's one
Yes.
question. Feel free to answer that and then I'll ask their follow-up.
Okay, yeah, sure. So they are using an embedding model, and they are calculating distances, and they are using LLM-as-a-judge. So the two main components when you're using Ragas is this choice of your embedding model and your critic model. So you do need to choose those. And in terms of what they're doing, I would refer to, there's a paper, and actually I tried to say it in my blog. Also, let's see, I have a part 1 of this blog. So there Yeah, actually, I think I would point to both of my blogs as follow-ups. Sachi, maybe we can send these out.
Yeah.
So my first blog is about how Ragas works and and um and kind of like their main concept is, I think somebody highlighted it, that when you statistically sample factual answers, they should be more similar to each other than hallucinated answers. And this is kind of what they're going off of. And then they do use LLM-as-a-judge to calculate all of these different metrics that you can see here. So yeah, taking segments of the question, taking little factoids out of the question, and then seeing if they're covered, for example, in the factoids of the context. Recall, precision and recall are different. So precision is more like the coverage, and recall is like how many of the points out were also mentioned. And then that's why typically statisticians calculate that F1 score out of precision and recall. Yeah, and also you need the ground truth answer for the recall versus precision. Sorry, I probably said that the reverse way.
Yeah, well, their next question was like, is it possible to produce any of these scores without ground truth specified? So
Right.
no,
So
right?
right. Yeah. So it is possible. I have seen some people using Ragas without a ground truth. It just means you'll be missing these three metrics. For example, you can't get the recall, and you won't be able to get whether the answer was correct or not, or similar in style. Okay.
Okay, great. So we have 1 minute left if anyone has any last minute questions. I think I see one here. Is this process pre-production evaluation or production evaluation / monitoring?
Yeah, I would do this pre-production as part of your development cycle before you deploy an app, because you probably want to iterate and figure out for your company's data what are, the levers that are going to get that you want to your best levers for your company. And there's even another layer on top of all of this, that the agentic RAG, where now you're adding, besides the LLM evaluation, now you're adding an LLM that can decide, for example, maybe the agentic RAG decides which chunking strategy, which embedding model, and which LLM to use. So I think it's still early days for agentic RAG, but it's getting a lot of buzz of, like, yeah, kind of the future of having LLMs make even more decisions for you. Yeah.
Cool. Thank you so much, Christy. Just to end, I see some speculations on what Ragas might mean.
Okay.
One is assessment, and another
Oh, good
said that
one.
Ragas or Raga is an Indian musical melody style. So they may have gotten the idea from there and saw that rag was part of that,
Okay.
part of the name there. Um, but yeah, thank you so much. We will send the recording, the slides, and some of Christy's blogs explaining more about this topic after the webinar has ended. Thank you all for joining today, and we'll see you next time.
All right. Thank you.
Bye.
Bye.